Good morning, everyone. Okay, so I hope everybody might have completed with the question which we were doing in our previous session. But still, since that was the first question of the BGAM method, I would be discussing that particular question. So we were left with the last iteration that I told that this would be the last iteration. So we would be doing the discussion on that particular last iteration, and then we would be starting with a new example for our practice purpose. So today now we would be having the practice of the BGAM method, and majority of the times you will be doing the questions because I will just mention how we can do the entire process. So you need to have the practice of this particular type of the methods, so that is the reason you will be doing the practice. Okay. So let's complete our previous question. Let me just open the whiteboard so that I can share the screen with you all. Okay, I've just shared the screen. I hope it will be visible. Okay, so this was the place where we were in our previous session. We have introduced the new variable, that is nothing but the x3 in our calculation. This variable was the entering variable because this x3 is belonging to the key column. Now this a1 is termed as the living variable because it is falling in the key row portions. Okay, so let's calculate the particular columns or particular rows in our new table. So how we can calculate it? We all know that how we can calculate. So whatever variable is there, in this case, it's x3 that is entering. So the previous values divide by the key element. So in this case, the key element is 10 by 3. So just divide 10 by 3 and we would be having the answer for our first row. So it will be 2 by 3 divided by 10 by 3. So if I can write 2 by 3 divided by 10 by 3, so it will be nothing but 1 by 5. So no need to show all these type of the calculations. These calculations are there in your rough page. But I won't remember this thing. I am just again highlighting these things that whenever you are going to submit me the exam for this particular type of the questions, or whenever you would be arranging the exam for this particular type of the questions, I want all the rough works. So how you can do the rough work? So there are two parts. First of all, let's say this is your page. This is your page. So just divide the page into these portions. Let's say this is your 4 by 5th part. This is your 1 by 5th part. So you can just divide it into these portions. This will be your rough work. Or you can also have it like you just divide it into this part, this type of the structure, where this is your fair work and this is your rough work. This is your fair work, this is your rough work. So I want this type of the structures in your answer sheet. I want the rough work to be shown the place where you have done the particular question. So I would be suggesting that in order to look nice, in order to have the freely attainment of all the questions, you just need to do one thing. You simply just take 1/5 part of the page as a rough work, or the right side or the bottom side. and you just do one iteration on a single page. Just do one iteration on the single page. Okay, just wait a minute. Okay, so I was just telling about how you can arrange the solution. So in that particular solution, you just do one iteration on a single page so that it looks nice. Okay, let's move to the second column. So it will be 0 divided by 10 by 3. So it will be 0 only. So this value will be 0. X3, it will be 1. This will be minus 1 divided by 10 by 3. So it will be minus 3 by 10. 4 by 9 divided by 10 by 3. So this will be 3. This will be 2 by 5. So if I'm not wrong, it will be 2 by 15. Next will be 4 by 9 divided by 10 by 3. So it will be okay, that we have done. And A1 is the variable which we have left out in this particular iteration. So it will be dash and dash. Okay. Now the next row, it is the previous value or the old value minus corresponding key row multiplied by corresponding key column divided by key element. So can anybody just quickly tell me what will be the answer? Just please quickly tell me what will be the answer of the entire row.
Sir, it will be 1 by 5, 1, 0,
Okay,
1 by 5 and minus 1 by 5.
fine. And the ratio, sorry, the solution
6 by 5.
6 by 5. Okay. So let's calculate the ZJ. For that, I need to write over here the coefficient. So coefficient of x3 is 20. Coefficient of x2 is 15. So just calculate ZJ. ZJ is 20 multiplied by 1 by 5. Now this type of the calculations, if you are quite comfortable enough, then just do it orally, or it will be better if you can just take the help of the rough work. Take the help of the rough works to avoid any further mistakes. So what you can do, you can just have it orally also, and if you want, you can do it as a rough work also. So 20 multiplied by 1 by 5 plus 15 multiplied by 1 by 5. So this will be the 3, this will be 4. So 4 plus 3, 7. Next is, this will be 0, this will be 15, this will be 20, this will be minus 3 by 10 multiplied by 20. So it will be minus 6. And this will be 3. So minus 6 plus 3. So it will be 3. Sorry, minus 3. 2 by 15 multiplied by 20. So let me do this. 2 by 15 multiplied by 20 minus 15 multiplied by 1 by 5. So this will be 3. This will be 4. So 8 by 3 minus 3. So this will be, what will be the case? It will be 9. So minus 1 by 3. And these are all dash. This will be 20 multiplied by 16 by 5. So it will be 16 multiplied by 4. That is 64. And 6 multiplied divided by 5 multiplied by 15. So it will be 18. So it will be 82. Just calculate Cj minus Zj. It is 7, 15, 20, 0, 0 mm. So it will be 0, 0, 0, 3, 1 by 3 dash dash. So these are all the greater than equal to 0. So that means our optimality is reached. What will be our answer? It is x1, x2, x3, where x1 is 0. It is not included in our iteration. So that means it is not playing the role. X2 is 6 by 5. And x3 is 16 by 5. So this will be our answer. This will be resulting in our iteration of 82 or the final calculation of 82. I hope this will be the clear to everyone. Anybody having any doubt in this particular calculation? I want acknowledgement from everybody. Okay, so let's start with our new question. So I'll be just showing the new question. So the same process, same approach should be adopted. Now there would be some twist in the question because I wanted to cover every variance of the question as much as possible so that you don't face any difficulty in the further iterations. Okay, just now start doing this particular question. Direct equations are being given. No need to do any type of the mathematical modeling. Start directly with the solution. Now just try to attempt it. I am giving you 3 to 4 minutes and then I will be telling you if you are having any doubt. Okay, what is the new thing that is there in this particular question? What is new thing that is there in this particular question? Anybody?
Sir, the second constraint.
Right? The second constraint is the equality directly given. So what should be done over here? So as a part of the solution, let me just start with the first step and then you can continue with this thing. Okay, the question is to minimize the z. Z is given to be 5x1 plus 3x2. The constraints are given to you. Constraints are, the first constraint is 2x1 plus 4x2. We know that in order to convert the inequality to equality, we need to add the slack or surplus or the artificial variables. So this is the less or equal to sign. So we have seen that the less or equal to functions are generally bounded functions. So we are only going to add the slack variable s1 equal to 12. So I will be just writing over here 0 s1. We have learned that whatever variables are there in the constraints needs to be there in our objective function. So I have just added 0x1. The second constraint, 2x1 plus 2x2 is equals to 10. Let it be like this only. We would be coming after we discuss the third constraint. 5x1 plus 2x2 greater or equal to sign. So we have seen that for that particular cases, we are going to have the artificial variable plus the slack variable. So plus 8 1 equal to 10. So here I need to mention 0s2 plus ma1. Why plus? Because it's the minimization. I have told that if it was the maximization, then you need to have the minus m because it is the penalty. Okay. Now over here, we are having the equal to sign. In each of the cases, we are starting with the dummy variables. We are starting with the dummy variables. And we have seen that these dummy variables, if they won't be playing any role in our function, then they would be leaved out. They would be dropped in our calculation. So don't use any slack or surplus variable, just use the artificial variable. Just use the artificial variable. Okay, so I will be writing over here A2. Just use the artificial variable because we need some variable to be started with. And these are all the variables, extra variables using which we would be starting our iteration. Now you can just make the simplex table for this particular case. It will be S1 as your basic variable in the first step. In this, it will be A1 in your basic variable first step. This will be A2 in your basic variable first step. And now start building the simplex table. I am giving you 3 minutes to just decide in the first iteration. I won't be solving the entire question in the first iteration, which is the entering variable and which is the leaving variable. Just decide that. Then we would be discussing the same thing for iteration 2, which is the entering, which is the leaving.
Sir, I have a question.
Yes.
Sir, if already it is given that in the second constant that it is equal, then why we need the variable?
Okay, fine. So that was the expected question. So there are two things. It is given that it is equal to sign. So we are in process of converting the inequality to equality. We are in process of converting the inequality to equality. Now, there are the chances that with this particular process of conversion, these two equations are dealing with the inequalities. These two equations are dealing with the inequalities. This equation is dealing with the equality. So there can be the chance, let's say for example, let me just take one example only so that it is better to explain this particular type of the concept. If it is x1 plus x2 is equals to 5, 2x1 plus x2 is less or equal to 6, and 3x1 plus 5x2 greater or equal to, let's say, 3. For example, this one. Or let me just take, instead of 3, some other value so that I can have the discussion more freely. Okay. So if this is the case, then suppose I'm selecting x1 to be 3 and suppose I'm selecting x2 to be, let's say, 2. I don't know whether this case will be working or not, but let me just check it. I don't know whether it will be working or not because I have just randomly picked up some of the alteration equations. Or let us just pick this particular equation only directly. It will be better for me also because that will be the validated equations. Let me just take this only. Okay, now just try to manually find out, the values of x1 and x2. What can be the values of x1 and x2? Just try to find out manually. I guess it can be 2 comma 3. Does it serve the purpose? No, it doesn't. Okay, 4 comma 1. Any other solution that will be working over here? Just try to check if any other solution works over here.
No.
Just okay, 3 comma 2 is another. 5 comma 0 is another. Okay, I haven't checked it, so you can just check it. Okay, let's submit with these 3 type of the answers. Now, even though we are having the equality sign, now if you remember, in the case of our solution of the graphical method, we were supposed to find the corner points. Okay, one person has to say 3 comma 2 doesn't satisfy. I don't know. 6 plus 4 10. It will be 6 plus 8 14. Okay, so I will be removing this thing. Even if I guess, if I am not wrong, 4.5 comma 0.5 might be satisfying. So 9 plus 2 11. So this will be satisfying. 9 plus this will be 1, so 10. This will be 5 into 4.5, so it will be 22.5, and yes, it should be greater. Okay, so this is the another point that can be satisfied. Okay, if you remember, in the graphical method we were used to find the corner points, and from the corner points we used to find the solution in order to determine which is the minimum most value. These are all called as the feasible points. Now, in this particular question, as a part of this question, it is not an issue because we are having only 2 variables and 3 constraints. So whenever we are having 2 variables and 3 constraints at that particular time, we are assured that we would be getting in our simplex table, we would be having 3 rows. This will be corresponding to first constraint, this will be second, this will be third. So that means we would be having 3 variables. Now, in these 3 variables, we are sure that, okay, 2 variables will be accommodated. because let's say there would be x1, x2, and over here some slack variable will be there, si or ai, anything. So that means we are having this particular values. But for suppose, just assume that there is no constraint over the objective function. There is no limitation of the objective function. For example, your objective function has four basic variables. That is nothing but x1, x2, x3, x4. And the same thing, you are having three constraints. Same thing, you are having three constraints. So what will be the issue over here, that corresponding to the three constraints, you can have at most three variables in the simplex table. So your simplex table will be having this type of the things, where this will be the first variable, this will be the second, this will be the third. Now in your objective function, you are having the four variables, four basic variables. So which three will be there over here? Which three will be over here? It can be x1, x2, x3, x2, x3, x4, or x1, x3, x4, anything. So if in this case, if we are not adding the artificial variable over here in this particular type of the cases, if we are not using the artificial variable over here, then we are giving a head start to one of the variables, because see, in the second constraint, we definitely need to select one of the variable. In the second constraint, we definitely want to select one of the variable. And with this process of selecting one of the variable, it is quite evident that we do not remove the basic variables. We do not remove the basic variables. So which are the prime basic variables? They are nothing but all xi's. So if in this particular case, if we are using this particular variable, if we are not using this particular variable, then we need to include either x1 or x2 in the second constraint. We need to consider x1 or x2 in the second constraint. And what will be the issue in this particular case? That we are giving a head start to one of the variable, and then we are considering that, okay, this variable is our variable which is occurring in our constraint equation, and that is the reason it is also occurring in our objective function, and that is the reason we are not going to remove that from our calculation, although it is showing the minimality or the maximality. So for this particular case, we are giving a head start to one of the variables, and that might lead to the alteration in our solution. So that is the reason we are only going to include the artificial variable. In order to prevent this biasness that is coming in the very initial stage of the calculation, we are going to add the artificial variable. Is this thing clear? Why we are adding, although it is there as the equality sign?
Yes, sir. And sir, here we can also add and subtract, like minus a1 also can work, right?
Minus a1 can also work, but the thing is that over here we generally don't put the constraint under the negative signs, because the if we are doing the negative sign, then it will be working in the opposite direction. So that is the advanced type of the technique that is there. But in this particular case, we are giving the penalty. And because of that particular, suppose if we are adding minus a1, then what will be the issue? That our a1, for example, if you are looking a1 is greater or equal to 0, we are putting the constraint like this one. Then if you are putting minus a1, then it will be going to reduce your values. In the constraint only, it will be going to reduce. So we generally don't force negative sign in this artificial variables in the constraints.
Okay, sir, got
Okay, so in the first iteration, which is the entering and which is the living variable? Anybody having any doubt? If you are having any doubt, then just let me know. I will be solving this question. But don't just sit idle. Okay, x2 is entering and a2 is leaving. So a2 is leaving and x2 is entering. Once you are done, just let me know about iteration 2. If anybody is done with iteration 2, then just let me know.
Sir, I think in iteration 1 it is A2 leaving and X1 entering. By mistake, I wrote X2.
Okay, x1 entering. Okay, I've got the response for iteration 2, and in iteration 2, x2 is entering and s1 is leaving. Okay, so let me write s1 and x2 for iteration 3. I don't know how many iterations will be there, so just let me know once the iterations are been done. So till this point of time, we are having in our question x1 and x2 been included. I don't know about iteration 3 whether it is going to be there or not. Anybody with iteration 3? If anyone is having any doubt, then you can ask me. Don't hesitate. If you are not getting, then please ask me. Okay, so there is one message that if I can explain this particular thing. Okay, so let me just start with the discussion of this particular question. Now I will be requesting the people who have done the particular solution to just guide me in getting the answers or in calculating the values of Cj minus Zj and Zj, so that it becomes easy and fast for me. Okay, so let me first draw the simplex table. So it is x1, x2. There are two variables. How many variables are there? There are two variables. S1, S2, A1 and A2. Over here, the coefficients are 5, 3, 0, 0, mm. In the basic variables, I need to include for the first iteration, I need to include S1, for the second A1 and for the third A2. 0 mm. This is solution. This is iteration 1. So just fill up all the values. So it is 2, 4, 1, 0, 0, 0 and solution is 12. Second is 2, 2, 0, 0, 1, 0 and solution is 10. A2 is 5, 2, then this is it's minus S2, 0, minus 1, 0, m and 10. Zj, for Zj it's 2 plus 5, 7m. 7m. For this second it's 2 plus 2, 4m. Over here it's 0, minus m, and okay, I just made a mistake. It's 1m, 20m. Now over here we will be checking whether all the values should be greater or less than 0. So let's see what should be the case. Cj minus Zj, these are all Cj's. So 5 minus 7m, this is 3 minus 4m, 0, m, 0, 0. So what should be the case? Whether it should be all the Cj minus Zj must be greater or equal to 0 or less or equal to 0. What should be the case over here for optimality? It's the minimization. So what should be there?
Greater than equal to 0.
Right. It should be greater or equal to 0. But over here, what is the case? So for that, if you are not getting whether m is infinity, so what should be done? So just assume m to be equal to, let's say, 10. So in this particular case, we are assuming m equal to 10. So 7 into 10, 76, 5 minus 70, so it's minus 65. In this particular case, it's minus 35, 0, 10, 0, 0. Find out what the most negative part. So it's nothing but this one. X1. So with reference to X1, just calculate the ratio. So ratio will be 12 by 2, 6, 5 and 2. So in this particular case, what should be our case? It should be the smallest most. That means this one. So that means this is our key row, this is our key column. So our x1 will be entering in place of a2. So let me just have my second simplex table. In this particular case, I will be having s1, a1, and instead of a2, I will be having x1. This is 0, m, and coefficient of x1 is 5. 5, 3, and 0, 0, m, m. This is what we are having solution. In this over here, we are having ratio. Okay, so if anybody can help me out to get the values. Please help me out to get the values of all the rows so that I can quickly just write it.
Sir, first row will be 0,
Okay,
16 by 5, then 2, then minus 2 by 5, 0, and then dash. And
okay,
solution will be 8.
8.
Then second row is 0, then 6 by 5, then 0, then 2 by 5, and 1, and then dash, and solution is 6. The third, that is 1, 2 by 5, then it's the same.
Right. Okay. Fine. So this is what we are having as our second iteration table. Now let's calculate Zj. So this will be 5. This is 6 by 5 into m plus 2 by 5 into 5. So it will be 2. This will be 0. This will be 2 by 5 into m minus 1. This will be m. This will be 1. And this will be 6m plus 10. So this is our Zj. Now let's calculate Cj minus Zj. It's 0. 3 minus this one. These are all my Cjs. 3 minus this one. So it will be 1 minus 6 by 5m. 0 minus 0, 0. This will be 1 minus 2 by 5m. This will be 0. And this will be, okay, sorry. Over here, we need to put dash. So this will be again dash only, because A2 has been left out of our iteration. Now just calculate key row and key column. So which is our key column? Which is our key column?
X2.
X2 is our key column, correct. Okay. So let me just highlight this one. X2 is our key column. And this is our key column. This is solution divided by the key column. So 8 divided by 16 by 5. So it will be, if I am not wrong, 5 by 2. 6 divided by 6 by 5. So it will be 5. 2 divided by 2 by 5. So it will be 5. Please check it if I have not made any mistake. And
Yes,
in
sir,
this
correct.
particular case, okay, so in this particular case, if this is the correct, then this one will be serving as our key row. This is our key element. So now again, let's have the iteration. So if I can just continue with the iteration, then it will be x1, x2, s1, s2, a1, a2. S1, sorry, in place of S1, we would be having X2. This is A1 and this is X1. Okay. Now, if anybody can help me out to find the values. Please help me out to find the values quickly. Let's take the benefit of the issue that sir is having. Let's have it 1 or 2 more minutes.
Sir, for the first row it is 0, 1,
Okay.
then 5 by 8,
Okay.
minus 1 by 8, 0,
Okay.
and solution is 5 by 2.
5 by 2. A1.
A1 is 0, 0, minus 3 by 4, 11 by 20, and 1, and solution is 3. X1 is 1, 0, minus 1 by 4, minus 3 by 20, 0, and solution is 5.
Okay. So let's say ZJ. So X2, what is the coefficient of X2? I need to check. X2 is having 3 M and this will be 5. So let's multiply this. It will be 5. Then this will be 3. And all these things will be 15 by 8 minus 3 by 4 M minus 5 by 4. This will be, I don't know, I need to have the calculation. So I hope you can just do the calculation of the entire equation. So it will be minus 3 by 20. So minus 3 by 4. And this will be nothing but M and then 0 and something over here. Okay. Cj minus Zj. What will be the case for Cj minus Zj? Over here it's 5, then 3, 0, 0, M and 0. This will be 0, 0. This will be turned out to be having plus 3 by 4 and something over here. This will be turned out to have plus 3 by, sorry, this is M. So it will be minus 11 by 20 M and something over here. This will be 0 and dash. Okay, so you can do one thing. You can just complete this particular calculation of Cj minus Zj. We will be doing the question from this onwards only. There is the last 2 to 3 minutes that we can just spare for this, but I have also the lecture in the 7th semester, so I may also not continue, although I want to, but okay. So you can just do the calculation and just let me know. In the next session, we would be having this particular discussion. More importantly, just take a note of one thing. On Thursday, on Thursday, that is exactly 1 week, in the same lecture. In the same lecture, the next week, we would be having the exam. The exam will be including graphical method and simplex method and BigM method. So in simplex, I would be including the BigM also, but still I've mentioned it. So we'll be having the exam of the graphical method, simplex method, and BigM method. I will be asking one question for each of these methods, and you need to complete it in 1 hour. Please take a note of this thing. On the next Thursday, I will be having this particular exam, the class test. I will be having the class test. Okay, so that's it. You can just leave the session. We will be continuing with this solution. Meanwhile, you can just write your roll number and name in the chat box, and you can leave and join the next lecture. Thank you, everyone.